Hi everyone, I am Dr. G. Srinivasu, Associate Professor, Department of Mathematics, Minister of Aeronautical Engineering, Dundigal, Hyderabad. In the present video, I would like to express the topic on Green's theorem in a plane. So already we have seen one theorem, that is Gauss divergence theorem, which comes under vector integration. Now we are going to see the Green's theorem in a plane. Clearly, it is a transformation between a line integral and double integral. Already we have discussed line integrals, surface integrals and volume integrals. And Green's theorem is a transformation between the line integral and double integral. So if you see the statement, suppose if C is in Green's theorem in a plane, it is a transformation between line integral and double integral. Let R be any closed region in xy plane bounded by a simple closed curve C, and if M and N are continuous functions having derivatives in R, then integral over the closed curve C, M dx plus N dy is equal to double integral over the region R, dou N by dou x minus dou M by dou y dx dy, where C is traversed in the positive direction, that is anti-clockwise direction. That means that, suppose if you consider the coordinate system xy system, and suppose if you consider a closed curve C, and the C is considered in the anti-clockwise direction, this is the curve C, and the region bounded by this closed curve region is capital R, then integral along the closed curve C, M dx, where M and N are functions of x and y which are defined on the curve, then M dx plus N dy over the closed curve C is equal to double integral over the region R, dou N by dou x minus dou M by dou y into dx into dy. So this is a line integral, this is a double integral, and this is equal to this when R is a closed region bounded by a curve C in xy plane, where M comma N are continuous function defined in the region capital R. So now this problem this statement can be proved by using problems, and here there are two types of problems in the model. One is verification problem, verifying Green's theorem, and other one is finding the line integral value using Green's theorem. Similarly, finding the double integral value using Green's theorem in a plane. So now we will do one problem, verification problem on Green's theorem. So now let me explain the problem here. Verify Green's theorem in a plane. The problem is like this: verify Green's theorem in a plane, and given integral M dx plus N dy over the closed curve C. Already M and N are already given. M is equal to this is, and N is equal to this is, where C is the region bounded by y is equal to root x and y is equal to x square. So what is y is equal to root x? This is y square is equal to x. It is a parabola symmetrical about x-axis, and other curve y is equal to x square. It is also a parabola symmetrical about y-axis. One is along symmetrical about y-axis and one is symmetrical about x-axis. This curve is y square is equal to x, and this is y is equal to x square. Here this point of intersection, this is vertex 0, 0, let it is O, and this point can be calculated by solving the two equations. Y root x, one equation, and y is equal to x square is another equation. So from the two equations, x square is equal to root x, or x power 4 is equal to x, or x into x cube minus 1, 0. So x0 is one value and 1 is other value. So remaining values are complex numbers, those we can neglect. The next 0, y0 and y is equal to 1. So the intersection points are 0, 0 and other one is 1, 1. So here the closed curve is OA and AO. This is the closed curve C. So this is along OA and along AO. And the direction should be the anti-clockwise direction. So we have to consider the closed curve is this is along OA, along AO. And the region is this portion. I hope that this will be clear. This is the region capital R. And also given that here m is equal to 3x square minus 8y square from the given problem. And n is equal to 4y minus 6xy. Then what is dou m by dou y? The partial derivative of m with respect to y. So when you are doing x terms as constant, so this is 0 and minus 16y is the first value. Similarly, dou n by dou x. Dou n by dou x means the partial derivative of n with respect to x. So y term treated as constant. So this is 0. Only you will get minus 6y. Now we know that by Green's theorem, integral over the closed curve C m dx plus n dy is equal to double integral over the region R dou n by dou x minus dou m by dou y dx into dy. Now we have to verify this result. This is satisfying or not, that we have to see. This is the verification of Green's theorem. So for that we need to consider the left hand side term and right hand side term. And if we show both are one and the same, the given problem is verified. So now I am considering the RHS part. Consider RHS. What is RHS? Double integral over R dou n by dou x minus dou m by dou y dx dy. That is double integral over R. What is dou n by dou x? Minus 6y. Dou m by dou y also already calculated, minus of minus 16y. So minus 16y minus of, that means plus 16y minus 6y, that is 10y dx dy. Now to find the limits of the integration for this region, we consider a strip inside the region. One is parabola, already I mentioned in the last slide. This is the region, this is 0, 0 and this is a 1, 1 and this is the region of integration. This is the region of integration. This is y is equal to x square curve. This is x is equal to y square. The lower edge of the strip is on the curve. Y square is equal to x or y is equal to root x. And the upper edge of the curve is on the curve y is equal to x square. So the limits for y will become y is equal to root x to y is equal to root x to x square. I hope this is clear. Already we have studied in double integral how to take the limits of integration for the given region. We have to consider the strip either parallel to y-axis or parallel to x-axis. If you consider the strip parallel to y-axis, then y limit will become a variable limit. If you consider a strip parallel to x-axis, x will be variable limit. Like that, the other variable, x variable will be the constant limit. So here y is equal to root x to x square is y limit, and x varies from, see the abscissa, it is 0 to 1. So these are the limits for integration. So I am using the limits at 10 constant right outside, integral 0 to 1, this is x limit, and y is equal to x square to root x or root x to x square, that is your choice. This is y square is equal to x, and this is y is equal to x square, because y square is equal to 4ax, this is the curve. So the limits will be y is equal to x square to root x. No problem. So only negative sign will get the change. So for finding the area, this is negative sign can be neglected. You can take the strip upper to lower or lower to upper. Generally we take from lower to upper value to get the positive value. 10 into integral 0 to 1 y limit x square to root x y dy dx. So on integrating, what we will get? Y means y square by 2 integration. Limits x square, lower limit, upper limit, root x of dx. So on substituting the upper limit root x whole square, that is x by 2, 2 5s are 10, 5 will be get outside, 0 to 1. Root x whole square, that is x minus x square whole square, x power 4 dx. So 5 into, this is x square by 2 minus x power 5 by 5 between 0 and 1. And substituting the limit 5 into 1 by 2 minus 1 by 5. So LCM 10, 5 into 2 5s minus 5 2s. So this is 3 by 2 is the evaluation of the right hand side limit. That is the right hand side value. That is double integral value. Similarly, we have to consider the left hand side value and you have to evaluate along OA and along AO. That will be the complete closed curve C. So now consider integral over the curve C m dx plus n dy, that is equal to integral over the closed curve C 3x square minus 8y square dx plus 4y minus 6xy dy. Now I am assuming I1 and I2, where I1 is the integral along OA and I2 is the evaluation of integral along AO. There are two integrals along OA and along AO. Along y is equal to x square, that is 3x square minus 8y square dx plus 4y minus 6xy dy. So along y is equal to x square, here you see the diagram for limits of integration. This is 0 0 and this is 1 comma 1. This is the curve y is equal to x square. This is the curve y is equal to x square. So along OA means the curve is y is equal to x square. Along y is equal to x square. So along y is equal to x square, dy is equal to 2x dx. So and x is a constant limit which is from 0 to 1. X is a constant limit from 0 to 1. So we have to evaluate the line integral along this curve between 0 and 1. That is our objective. So integral 0 to 1, 3x square, 8 into y square. Y means x square whole square dx. I'm getting substituting the value of y is equal to x square and total function will get in the terms of x only. Wherever you have y, that will be replaced by x terms. Plus 4 into y means x square again. 6x into y means x square again. Dy means 2x dx. So I'm substituting all the terms. You'll get integral 0 to 1, 3x square minus 8x power 4 dx plus 8x cube minus 12x power 4. 4x square into 2x, 8x cube minus 6x cube into 2x, that is 12x power 4 dx. Or I can write integral 0 to 1, 3x square as it is, 8x cube also as it is, minus 12 minus 8, minus 20x power 4 dx. So on integrating 3x cube by 3 plus 8x power 4 by 4 minus 20x power 5 by 5 between 0 and 1. So on substituting the limits 3 by 3, 1, first value, second value 4 2s are 8, so 2 minus 5 4s are 20, that is minus 4. So 3 minus 4 means minus 1, which is the line integral along OA. Similarly, you need to find along AO also. Along AO, that is in the anti-clockwise direction. So what is along AO? X is equal to y square. Here x is equal to y square. Dx is equal to 2y dy. And the total function getting the transform I2 is equal to integral x limit 1 to 0. Here you can see that 1 to 0, x1, 0, direction also important, 1 to 0, function 3x square minus 8 into y square means x, dx as it is, plus 4 into y means root x, y square is equal to x, y is equal to root x minus 6x into y means again root x, along the curve. This is the curve, along the curve y square is equal to x, right? Into dy. What is dy? 2y dy. Or you can replace x for y square. I will write here. This is along AO. Integral along AO. Along AO, the function 3x square minus 8y square dx plus 4y minus 6xy dy. So along AO means the curve is along AO. This is the curve. This curve is y square is equal to x or y is equal to root x. Y square is equal to x or y is equal to root x. Then dy is equal to 1 by 2 root x into dx. Dy is equal to 1 by 2 root x dx, or x square is equal to y, 2x dx is equal to dy. So you can change the entire terms in y also. So I can replace 3y minus 8y square. Suppose if you replace x square is equal to y, then what is the dx? 2x dx. I can replace here dy is equal to 2x dx. Right. 3x square minus 8y square means x power 4. Am I right? Y square x power 4 dx first term plus 4 into y means x square. Y is equal to x square or y square is equal to x? There is a little bit confusion here. This is y is equal to x square. This is y square is equal to x. Not this is y square is equal to x. I will go to the next slide and I will do this. O0, 0. A1, 1. Along AO I need to calculate. That means the curve is, what is this curve? What is this curve? I will show. This is y is equal to root x. Y is equal to root x, this curve. And along this you have to calculate integral along AO. What is the given function? 3x square minus 8y square dx plus, what is the second value? 4y minus. So this is the integral to be evaluated. Along AO means this is the curve y is equal to root x or y square is equal to x. You can take any one. So if you put x is equal to y square, then dx is equal to 2y dy. So we can take, this is integral 3x square same, 8 into y square means x, dx as it is. And if you take common 2y outside, then you will get 2 minus 3y. Am I right? 2y into 2, 4y. 2y into, this is 3x. 2 minus 3x into 2y dy. 2y dy can be replaced by dx. That is the integration. And here the limit x for 1 to 0. So the function, entire function changed into x term. This is integral 1 to 0. This is 3x square minus 8x plus 2 minus 3x of dx. Or integral 1 to 0, 3x square minus 11x plus 2 of dx. So I'm integrating 3x cubed by 3 minus 11x square by 2 plus 2x between 1 and 0. 3 cancel, upper limit 0, 0, 0 minus lower limit 1 minus 11 by 2 plus 2. This is equal to minus of 3 minus 11 by 2. That is equal to minus 3 plus 11 by 2 or 11 minus 6 by 2, that is equal to 5 by 2. This is the value 5 by 2. So I will check it out the value first. This value is 5 by 2. I2 is equal to 5 by 2. That is the second integral value. So the first integral value already we have reached the minus 1. Therefore, the complete integral over c m dx plus n dy is equal to first minus 1, second one along OA minus 1 along AO 5 by 2, that is equal to 5 minus 2 by 5, that is equal 2, that is equal to 3 by 2. So we already calculated the double integral value, that is also 3 by 2. Therefore, Green's theorem verified. That is the required solution. I hope this is clear for all of you. So I will do the same, for the same function I will do another problem. If you have any doubts, so it can be cleared by using this problem. This is also a verification problem. So this I will do next. Then what is another problem? Is there any problem? So I will do verification problem first. So for the same function, you need to calculate the line integral and double integral, and we have to show that both are one and the same. That is the problem. And here I will remove all the things because. So now see this problem. Verify Green's theorem for the function integral over the closed curve C 3x square minus 8y square dx plus 4y minus 6xy dy where C is the region bounded by x is equal to 0. So see this x-axis, y-axis. Y-axis means x0 and x-axis means y is equal to 0. And other one is 1 comma 0. This is 0 comma 1 because it is the line x plus y is equal to 1. This is a0 comma 0 or this is o0 comma 0. This is a1 comma 0. This is b0 comma 1. And clearly it is a closed curve. It is a closed curve. It is along OA plus along AB plus along BO. So that will be the total closed curve. And we have to evaluate the line integral along OA plus along AB plus along BO. And also we have to, this is considered as the region capital R. And we have to consider the double integral according to this area. And what is our Green's theorem? We have by Green's theorem, first write the statement, integral for the closed curve C, m dx plus n dy is equal to double integral over R, dou n by dou x minus dou n by dou y dx dy. That is the statement of the theorem, where C is the simple closed curve and R is the region bounded by that curve. And the line, so to verification. So verification. So LHS. Integral over the closed curve C, m dx plus n dy is equal to integral along OA plus along AB plus along BO. So along the closed curve C, the complete curve means this is complete curve. So OA is along, that is one curve, along AB is one curve, along BO also other curve. So we have to evaluate the line integral along AO, along OA, along AB, along BO. And also I will discuss here. So along OA means the equation of x-axis y0, then dy0. y0 and dy0, and x varies from 0 to 1. X varies from 0 to 1. That is the line integral along OA. Similarly, along BO, the equation is x plus y is equal to 1 or y is equal to 1 minus x or dy is equal to minus dx. And here x varies from 1 to 0. X varies from 1 to 0. Here I am writing at the diagram only. And what is the equation of BO? BO equation is y-axis. This is x0 implies dx0. But y is a variable limit which is varies from 1 to 0. Y varies from 1 to 0. That is the line integral along the closed curve C. So now how to evaluate? So first along OA, integral over the closed curve C is equal to, already I have written. I am writing integral along AB, line integral is integral along OA. What is the function? So just see the 3x square minus 8y square dx plus, what is the second term? 4y minus 6xy. 4y minus 6xy dy. So what is along OA? X-axis equation y0, dy0, x varies from 0 to 1. So dy0 means entire term 0. So y0 means this 0. What you will get is 3x square dx. Limits are 0 to 1. That is 3x cubed by 3 between 0 and 1. That is 1 minus 0. That is equal to 1. So that is along OA. Similarly, the line integral along AB. So along AB, what is the equation? X plus y is equal to 1 or y is equal to 1 minus x and dy is equal to minus dx. But x varies from 1 to 0. So already I have seen at the diagram, x varies from 1 to 0. Here you can see that x varies from 1 to 0. So that I am writing here, x varies from 1 to 0. Therefore, integral along AB 3x square plus 8 into y means 1 minus x whole square dx plus 4 into y means again 1 minus x minus 6x into y means 1 minus x of dy is equal to minus dx, and x varies from, here you can write x varies from 1 to 0 along AB. So the equation x plus y is equal to 1, the line equation. So that y 1 minus x dy is equal to minus dx. So on expanding, what you will get 3x square. I will write here 3x square plus 8 into, I'll write here 3x square plus 8 into 1 minus x whole square, 1 plus x square minus 2x. That is 8 plus 3, 11x square minus 16x plus 8. That is the first term. And here, this is 4 minus 4x minus 6x plus 6x square with a negative sign. With a negative sign. So 11x square minus 16x plus 8 minus 4 minus 10x, that is plus 10x minus 6x square. So what is the value? 11 minus 6, 5x square and minus 6x plus 4. So the entire equation I will write here. I'm writing this is what you will get. Integral, after simplification, this is integral 1 to 0 5x square minus 6x plus 4 dx. So what is the integration? 5x cube by 3 minus 6x square by 2 plus 4x between 1 and 0. So upper limit entire term 0, x 0, this is 0, this is 0. Lower limit 5 by 3 and this is minus 3 plus 4. That means what? LCM is equal to 3, 5 minus 9 plus 12. That is 17 minus 9. That is equal to minus 8 by 3. This is along AB. Similarly, you find along BO also. Along BO. So what is along BO? The equation is y-axis. The equation of y-axis is x is equal to 0. So the dx is 0. But y is a variable limit here. What is the y variable limit? Y varies from, I can see that, y is the variable limit from 1 to 0. Y varies from 1 to 0. So integral this you can calculate x 0, first term entire term 0, second term also, this second term 0, we will get only 4y dy between 1 and 0. This is 4y square by 2 between 1 and 0. That is 2, 0. So what you will get? y0 minus 2. So this value is minus 2. Therefore, on adding all these three values along OA plus along AB plus along BC, you will get 1 minus 8 by 3 minus 2. Or 3 LCM, 3 minus 8 minus 6. That is equal to 3 minus 14 by 3 or minus 11 by 3 is the first value. So similarly, find the double integral value and you show that both are one and the same. What is the double integral value? Just you consider a strip inside the region. Here y0 to y is equal to 1 minus x. So double integral value integral 0 to 1 minus x. The function dou n by dou x. What is dou n by dou y here? So I will see the second part. Just you try to do this. Just I will explain. And you make use of this information, you try to solve it. Here what is m? This is 3x square minus 8y square. Then what is dou m by dou y? That is minus 16y only. And n is equal to 4y minus 6xy. And dou n by dou x is equal to minus 6y only. Minus 6y. Then double integral. So dou n by minus 6 plus 10y. As last case in the problem, dx dy. But here y is equal to 0 to 1 minus x and x varies from 0 to 1. So what is the integration? First integration y square by 2 10 outside, y integration y square by 2 0 to 1 minus x of dx. So 2 5 is 10, so 5 into integral 0 to 1 minus x whole square dx. Or 5 into 1 minus x whole cube by 3 between 0 and 1. So I'm substituting the limits, upper limit 5 by 3 into upper limit. I'm writing this is 0, lower limit 1. So this value is minus 5 by 3. The double integral already we have calculated minus 1 by 3. And the upper limit also we reach minus 5 by 3. So that will be the total, this is, am I right? Minus 5 by 3. 2 5s are 10. 0 to, here we have done some value. 1 minus 0, there is one value. 5 by 3 minus 17 minus 9 minus 8 by 3. And this is 0. 0 upper limit 0. 4y square by 2 minus 2 minus 1. So here there is some value along AB 3x square. There may be this 17 minus. So here I will do that. I will see once I will check once again this value. I will check this value. Integral 1 to 0 3x square plus 8 into 1 minus x whole square plus 4 into 1 minus x. So this is minus. You will get minus sign here. 1 minus x whole square minus 4 into 1 minus x plus 6x into 1 minus x dx. So I'm taking out. So you after simplification, you can take 1 minus x is common. So 1 minus x I'm taking out. 8 into 1 minus x minus 4 plus 6x. That is 3x square plus 1 minus x into 8 minus 8x minus 4 plus 6x. So what is this value? Minus 2x plus 4. 4 minus 2x into 1 minus x plus 3x square. That is 4 minus 2x minus 4x minus 6x plus 2x square plus 3x square. That is 5x square minus 6x plus 4. That is 5x cubed by 3 upper limit. So this value 5x cubed by 3 minus 6x square by 2 plus 4. On implementing and substituting the limit 1 and 0, I will get the values, and substituting you will get minus 5 by 3. That is the required solution. So in this way you can solve verify the Green's theorem in the plane. So similarly we can, this all, the reference book is Mathematical Methods by S. Chand Publications, year 2006, and I have taken all the problems from that only, and this you can see that verification problem in Green's theorem in the plane. So to get more clarification, the next video also will be on the same Green's theorem. We will do some more problems to verification and some problems to find the values of double integral and single integral. In the next video, we will do some more problems on Green's theorem. So thank you. We'll go these problems in the next class, and thank you.
Like, share and subscribe. Hit the bell icon for more updates.